Hey guys, welcome back to my channel. Thank you very much for joining me. For today's video, we're going to talk about what is the residual. So the residual is basically the error made by your linear model, which is also known as your line of best fit. In some cases, you'll hear the least square regression line. If you think about it graphically, it's going to be the straight line you see going through your graph, which has equal amount of dots on either side. To calculate your residual, it's denoted by the letter E, and it's equal to y minus y hat, where E is your, not touching, okay? E is your residual, y is your observed, RVED, your observed value. Some persons here say the actual value, and VALUE. And y hat is going to be your predicted value. So when you think about the predicted value, this is basically the prediction made by your model. And your prediction can either be accurate, it can be an overestimation, or it can be underestimation. So if your residual is negative, we say that the model overpredicted or overestimate the actual value. If the residual is positive, we say the model underestimates it. If the residual is 0, we say the model made an accurate prediction. As you can see, I gave you some notes here. You can always read them and see basically what they're saying, or I'll explain to you on the slide to come. So, what is the importance of the residual? The residual and the residual plot will help us to determine if the linear model is appropriate or not. Hence, you know if your straight enough condition is met or not. So to tell if your linear model is appropriate, the dots on your scatter or your residual plot should be randomly scattered. If they are randomly scattered, you know that your linear model is appropriate. If you see a curve within your residual plot, you realize that your linear model is not appropriate because a trend or pattern exists, which means another model can use to fit the variables or the scenario you're given. All right, when it comes down to the residual, you realize that the sum, meaning adding up all values, and the mean is equal to 0. Because if you look at what an actual graph looks like, let's see if you can find a graph. Yeah, an actual graph looks like, you realize that at one point, all of these errors the model made will eventually cancel out each other, which makes it a straight line, which is also equal to 0. So you'll realize that if you should add up all of these runoff or residual, it should always be 0 for your answer. Alright, so what the residual looks like graphically when we say the error made by the model. So the actual is what you're seeing in blue. So the actual value here, that's your y. In this case, it's going to be 0.7 or something like that. 0.7, and the model predicted it to be 0.5. So the actual thing would be somewhere here, and the model predicted it to be here. So in this case, you realize that the model underestimated whatever this point is. And so that's how you basically look at your residual plot. If from this line, for your residual plot, when you're graphing this, we graph our independent variable, which is your x variable, with the residual that you find. In most cases, some teachers will tell their students to use Desmos graphing or their T184 calculator, and you should see a plot looking like this. So we plot our residual, positive or negative, on our x-axis. So with this, again, to tell the appropriateness of your linear model, you check to see if a pattern exists or not. If a pattern exists, the linear model is not appropriate. If the dots are randomly scattered, it is appropriate. And once you can graph your residual plot and justify the appropriateness of a model, in specifically the linear model, you should be fine. And I hope this short video was useful for you. If it was, let me know in the comment section below. If not, leave me a question and I'll be happy to answer this for you. And I'll see you on the next video.